From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We had seen, it wasn't one of our products, but we had seen a scenario where a blade had come dislodged. And we were like, well, all of our systems will prevent that. We know that, but we want to give people that extra level. So we put more time into R&D, and now we have what we call the foil retention system. So this is a high quality nylon strap that was taken, and it attaches to the center of the hub at the point where it mounts to the motor or gearbox. And it runs all the way down the blade and attaches at the other end. So even if a blade broke or a spar broke, or then you somehow broke the retainer and you somehow sheared the, the bolts that we specify, it would still stay up. It would still stay in the air.
That was Mike Smith. Mike is a prototype and design engineer at Big Ass Fans in Kentucky. He joined our show today to talk about his career in additive manufacturing. He also shares some insight and great advice on how to search for and implement 3D printing applications within an organization that may not be accustomed to the technology. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. All right, Mike, thanks for joining the show today. You and I met up at AMUG a few weeks ago here, and kind of following up on that conversation, kind of like what you're doing, kind of enjoyed the conversations that we had on site here in Chicago, and excited to hear your story. So I think I always like to get some context with all the guests that we talk to, and let's start with the basics. Kind of where you're from, where'd you grow up? Then we'll go from there.
Yeah. So I'm born and raised in Kentucky. I spent a short stint in Florida, but I've been in Kentucky most of my life. And, not exactly a place that you'd think to stumble into 3D printing or any kind of tech innovation for that matter. It's all horses and bourbon here, right? But yeah, I was lucky enough to have a friend move back from California who was also from the Kentucky area and exposed me to the 3D printing world. And we basically, I was an IT guy. So my love of anything IT, we talked and joked and saw 3D printing as the future, just like people talked about desktop computers in the 90s. And so that was our approach, was we were going to be the Dell of 3D printing. But background in IT gave me really good insight for software and working with 3D printers. And then I kind of picked up the mechanicals and the electricals of working and designing and building 3D printers. Was with that company for a long time, and was a partner in the company, and then eventually landed at Big Ass Fans where I'm at today.
Awesome. So was that kind of early days? Were you doing mostly like filament-based printing?
Yeah, I'm still primarily an FDM guy, familiar with all the other technologies, but I've always had a really strong focus in what I've always called like low cost, high efficiency printing, right? Because if you can do something cheap and fast, it really tends to turn heads.
What was the appeal to kind of go down the path of kind of working with this new technology, kind of starting in kind of this new business area? Like what kind of drove you to do that? Because it's not every day that, you see that in people.
Yeah. Honestly, it was kind of just fascination. When I initially kind of started working with the 3D printing startup, it was just a guy and his cousin's boyfriend was my best friend, and we were introduced, and I literally was just kind of a hangabout. Like I would just go hang out at his shop just to learn about it. But it was one of those things that just sort of immediately was enthralled with, right? Like I was like, this is the future, man. Like we were both like that, and we fed off of each other. And so a lot of it had to do with his excitement around the technology and my interest, and sort of giving the two of us an opportunity to dream and aspire and talk about, oh man, we're going to do this and do that. And so it was, I had a battle buddy. And that was, and it also made it really tangible. Years prior, I'd heard about 3D printing or seen stuff online, and it was this intangible, cool technology. But, I'm a take things apart, put things together, want to know how it works, big picture, kind of guy. Like it's not good enough that it works. I got to know how it does. And so being able to put my hands on it and like really make it tangible, make it something that like I could get deep in to the point that I could explain it to other people. And I'm a huge nerd. Like anything I do, I'm going to jump straight into and learn everything about it. My experience with Big Ass Fans, I didn't start working there as a fan expert by any means, but I can give you all kinds of information about airflow stats and, like different fans and efficiencies. And like, it's just anything that I do, I'm the kind of person who's going to sort of pour my heart and soul into it to some extent.
And so as you're kind of working in the small company, like what year is this? Like, kind of give us a time frame.
So it was about 10 years ago. So or well, maybe not quite 10, so 8 to 9 years ago, we'll say. So kind of early on in the infancy of 3D printing, especially on the hobbyist user desktop 3D printer side, the Stratuses and stuff of the world have been around for a long time, but this is when it's first becoming tangible. When I was doing it, the way that everyone talked to each other was Google Plus, if that gives a great indication of dating my level of involvement. And what was great about those days was that the Google Plus forums included everybody. It wasn't just the small guys like me and my buddy who were trying to do something in Kentucky. It was guys who were patenting ideas. It was guys who were, the owners of MakerBot, I think some of the Form Labs guys were on there back in the day, but this is at that point, you're talking about all these big names that we know as sort of the staples of desktop 3D printing were 10 employees deep. And they were sort of trying to figure it out just like all of us.
And so at that time, what was the business approach that you guys were trying to take? Was it to sell printers? Were you like finding traction and like doing prints for people or educating about it?
Yeah. So if you would have asked us then, we would have said all of the above. Right. So
you gotta be scrappy when you're small.
Right. Well, and we didn't really know where people were going to be interested. Right. And so we had kit printers. We were mostly working with some guys out of California who made two printers called the Bukido and the BukoBot. Long gone now, but they were just rep kits with some custom firmware that those guys had written. So we would build kits and we would sell kits to people, but then that's not enough to tie up your every day. So we were also printing as a service. So we would be like, oh yeah, we're the Kinkos of 3D printing. But on top of that, we also were involved with a makerspace in Lexington called Create Now Makerspace. And we were doing day-to-day there. It was giving tours throughout the makerspace or bringing guests in. We've talked to the mayor. We've talked to various political figures, Chamber of Commerce stuff. And so we kind of did everything. And it was, we always said we were 3D printing evangelists. If there was an opportunity for us to talk to somebody about 3D printing, we did it. And we'd work out the logistics of, what the business truly was kind of in the process. Today, the business is still around. It's doing very, very well. I've stepped away. My friend has continued on. And it's only grown year over year and done very well. But he primarily focuses on printing as the main business because that's what seemed to be the most reasonable thing to do. But the difference is now we're not just printing for singular people. Like he has corporate clients that come to him for stuff. And he still sells printers, but that's really an auxiliary thing. Someone comes in and spends thousands and thousands of dollars in services. Eventually they go, maybe we should just have one of these at our place, just like everybody else. So.
And were you doing that full time? Was that kind of your full time thing at that stage?
Yeah, sort of.
Yeah.
So I was doing that as my full time job for a period of time, but also during that same thing, it was a startup. We basically were doing well enough to both make about minimum wage for a period there. And I worked for Geek Squad. I'm a certified Geek Squad agent. I have the badge to prove it. I was a dog trainer, and kind of during this whole period, I was also in a metal band where I would tour and play bass. So I've done a little bit of everything, but it all goes back to that kind of mentality of just, it seems cool, let's do it,
So, yeah, I remember my first year doing kind of my business, I think I made $12,000 for the entire year.
Yeah.
And so you got to find
Right.
other things to do. So,
Yep.
Okay. So like, what was then the transition to Big Ass Fans? Was it kind of directly from the startup over to there, or were there some middle steps there?
Yeah, so there were some overlapping years. The makerspace that I mentioned, the way that this really all kind of came about was they had invited the makerspace or someone from the makerspace to come talk at Big Ass Fans or visit Big Ass Fans. It was a talent seeking event. They invited a bunch of programming groups in the makerspace, and we're trying to bring people in looking for talent for Big Ass Fans. They called the head of the makerspace, and he said, "I have prior engagements." So he called me and he said, "Hey, you do anything tonight?" I said, "Of course not." So I showed up, and the thing was that they planned on everyone coming there and showing products and talking about the cool stuff that they were working on and trying to gauge prospective employees is what I garnered after the fact. Me being almost oblivious, I thought, I know, I'm going to bring my portable 3D printer with me and I'll set it up on a table and then I'll just talk about 3D printing. Again, it's the evangelizing, right? They gave me a platform, I used it. So I did that, and every manager in the building that was part of this event came over and talked to me, including the owners and the VPs. And so one of the VPs happened to live across the street from me when I was, a teenager. Didn't even know he was still at the company. And he was like, "What are you doing?" I said, This is what I'm doing. And he's like, "Well, if you ever want to do it for us, let me know." And I was like, "Yeah, keep an eye on it. I'm an IT guy. I'm not it's fine. Well, you guys let me know when you want to get into it." So, a year or two goes by and I land in an opportunity to go work in their R&D department. When I started, I had 3 bosses because no one knew exactly what to do with a 3D printer guy with no engineering experience. So one day I would report to this person, the next day I'd help out this guy, and next person be working with this girl. And so I just kind of bounced around. So I was hired on for 3D printing, but no one knew what to do with it. And at the same time, I was working with Art Lab on the side at the startup, and still going in and running prints or working with Ben on what the future may hold. Just lots of different stuff. So it was a slow, gradual process with a lot of overlap. So,
and tell us a little bit more about Big Ass Fans. Obviously, the name says what you make.
Yeah.
Like, how big's the company? Like, what's the people who may not be familiar with it? Kind of what's the main product? What's the main business? And kind of scope of the company?
Yeah. So we are a fan company. We tend to make, and our original product was large overhead fans. You see them very frequently in gyms, airports. If you've ever been to a Planet Fitness, the big purple fan with the yellow on it, that's us. And that was kind of the start. Eventually we did kind of move into other products, more fans. We have home residential fans that are, will fit in normal rooms, not just giant gymnasiums, which some people do find surprising, but we do offer that. And since I've been there, the business has kind of grown beyond just the overhead circulators and I think we had 3 models of what we call directional fans. And these are the kinds of fans that you would see kind of rolling around. And so we had those, and then we made a smaller kind of standard cage fan that you'd see at a lot of warehouses or outdoor events, things like that. And more recently, we've gotten into the world of evaporative coolers. We also did clean air technologies through COVID. There's a big push for how do we deal with this new thing no one really knew, and so we looked at using ion technology and UVC in combination with air circulation integrated with our fans as a means of cleaning the air. So we do a lot. We're not just a fan company. We aim to be the best and to kind of fulfill the needs where we see it.
So do you manufacture it all in Kentucky too?
Yeah. So everything's based in Kentucky. We do have some locations outside of Kentucky, but we're between 500 and 600 employees, I think, currently. And I would say 550 out of that 600 work in Kentucky. But we're an international company, so we do have offices in Asia, Europe, all across the US for installation and technical. We have lots of showrooms across the US. in various places. Kind of similar to like a company like a Herman Miller chairs. Like there's not going to be a showroom in every town next to the Walmart, but if you go to a Dallas, Texas, or Austin, or some bigger city, that will have either a standalone showroom or some kind of association where we're working with another premium showroom where you can go in and actually see our products. Beyond that, we're at every trade show that has anything to do with industry.
And did you know about the company? I mean, you said your neighbor kind of worked for them, but were you aware of them before you started working there?
Yeah. So I probably found out about Big Ass Fans when I was 15. Sounds right. Maybe even sooner. But the original owner was an eccentric kind of guy. And so every building he had giant, like either words or a giant fanny, which is the logo or our donkey logo, painted on the side of the building. So if you lived in Lexington, you went down any of the major streets where one of his warehouses was located, you were aware of who Big Ass Fans was.
And so kind of you start out, you've got 3 bosses. Mm-hmm. Like how was it organized? Like where was it like R&D? Was it like design, like new product? Like what was your starting role there?
So all 3 bosses were R&D. There was kind of a top guy and then 2 people under that. The division there was sort of the top guy was all R&D and more like innovation and new product stuff, things that may or may not exist until 2 years down the line. Then you had sort of our other R&D division, which was a lot of interns and academics and people who would do a lot of research and white papers and stuff like that. And then sort of the third division of that was our testing group. So we have a massive testing facility. One of the only ones, we're the only fan company who has our own testing facility. We have 4 separated quadrants, 60-foot ceilings, and they're 100 feet by 100 feet. So this is because we hang, these giant overhead fans and we want to test and we do all the airflow testing. And so we'll literally be measuring, every foot and then doing calculations, or we have massive torque thrust cells that are collecting data, and we'll do the calculations. And so there's a lot that goes into our product on the testing side. And so part of the benefit was I was involved in all of that. Right. And over time, it sort of just narrowed down to where I was reporting to the top guy. He's still my boss today, 6.5 years later. And from that point, I basically had expressed that I liked doing like 3D modeling. I don't know that I would say I was good at that point. Most of my experience was in SketchUp. This is a company that's solely rooted in SolidWorks. So that was a big jump. But the way that I integrated 3D printing was they didn't have a 3D printer there for me to use. They didn't really know what to do with it. So it wasn't like they were going to be like, here's 10 grand, good luck. So I literally brought my own 3D printer in. And it's little $1,000 half Cartesian. I've actually got it sitting behind me. But it wasn't anything special. It just printed PLA. And so I brought that in for one project because our EMC engineer needed a bracket. And we couldn't machine it at the time due to timing or materials. And so I was like, I'll go grab my printer. We'll do that. So I just started bringing that every week. And that evolved into, okay, well, yeah, you can just design stuff for your 3D printer. You don't work on products, but you can design test fixtures. Okay, that's fine. Give me an inch. I'll take a little more every time. And over time, that got me to where it was like, when we talk about developing stuff, the conversation would go, well, I wonder if Mike can 3D print it, right? And so I'd get crazy ideas, I'd get practical ideas, I'd get stuff where I'd be like, no, we can push the envelope just a little bit more. And so that was it was a slow trickle, but the way that I had to do it was almost by force. I had to be like, here's a 3D printer, here's all the things we can do. And that's still an issue in the industry today, right? People go, oh man, this thing can do all this stuff. Where do I start?
For sure. And I mean, from your skill set, that's something like you get pulled into a lot of different projects, but then you got to interface, you got to kind of sell it a little bit. And so you're doing all these different things at the same time of figure out the printer, the material, the part, and what works, CAD, and so you're you're wearing a lot of hats. It sounds like.
Yeah. And today I'm a design engineer with the company. And so I came in as a 3D printing guy that no one knew what to do with, and have slowly worked my way up into being one of the lead engineers, and work on and have gotten patents for my designs across pretty much all of our product lines at this point. So it's been a really interesting road. Like, this is not what I would have ever envisioned, 7 years ago before I started there. But I think the important thing is, to me, like when I go back and think about it, is that 3D printing I was ahead of the curve in some extent, and that gave me the opportunity to open a lot of doors. I was right place, right time. But I think that's kind of the joy of 3D printing. And I still feel like that's the case today for someone who's trying to get into the 3D printing world. If you have an aptitude for engineering or design, and you can pair that with the skill of, being able to 3D print, even if it's just at like a hobbyist, I have my own printer level, and then you take the initiative to sort of drive that, it's kind of game changing, because now people are way more interested in my resume, but they weren't interested necessarily in where I went to college or what class I went to. They were interested in this 3D printing startup. Like, tell me more about that. What can we do with that? What can we 3D print here? Right. And I didn't go to college. And so this was college for me. This was what I sort of slotted in to open those doors.
You had a super practical skill that was highly relevant for what they were doing. And so when you first came on, kind of was your remit to kind of be the 3D printing guru guy, but then also were you trying to build a facility, or relying, you had your printer there, but kind of outsourcing some of that, kind of getting parts printed? Was there an initial philosophy, or they're hey, we need this, and go figure it out?
Well, so there was a 3D printer on site. They did have an old, it wasn't at my building, it was at one of the other buildings, but they have an old Stratasys Dimensions 1650 that the way the story goes is that it was bought sight unseen by the owner. He said, "This sounds really cool. How much is it?" And they said, "It's $30,000. He said, "I'll give you 22 if you leave it today." And they did. So behold this technology that's been tossed into the middle of the engineering group, and they're all sold on how great it's going to be. But no one knows what to do with it. And so it gets used a little bit here and there. Nothing really functional is ever printed. It's always we have the circuit board we're going to order. Can we 3D print a model of the circuit board to make sure it fits? Yeah, sure. Do that. Or we've got this, little piece that we're making. We want to make sure it falls into place. So we'll, print it. But at that point, they weren't even using 3D printing for things like fixtures or kind of design verification, other than just simple parts. But now, we'll have an entire control enclosure where the prototypes will be 3D printed, kind of through and through. And that's sort of what we use for our design criteria to say, well, how does this feel in your hand? And obviously for some of our larger stuff, we sort of have to cut it down, do it in pieces. But it's enabled us to iterate so fast. I mean, I've been doing it long enough that my entire design workflow is I design a thing, I print a thing, and the first one, I wait for it to come off the printer, get it, I figure out what I want to change about it, because then I can put all the pieces together. Start the second one. While the second one's going, I'm continuing to make changes. So I already know number 3 is coming out before before number 2 is done. And so I'll do this until I basically solidified my idea. With traditional manufacturing, when we were, have to rely on injection molding or something like that, you'd go, I made this, I've painstakingly thought about every little nook and cranny, at least I hope. Let's send it to the molder, and you spend 10, 20, 30, 50 grand, depending on what size it is. And you wait 4 to 8 weeks, then you get your part and you go, I hope this works. Right. Whereas I was doing it tomorrow. right? That was the advantage, was I could always, just about always have the thing tomorrow. That was the longest I really had to wait to. And I think what I lacked in experience in design, the fact that I could just constantly iterate and fail as fast as possible, let me learn really quickly. Like, what should I have, lessons learned from the past, what should I do, what should I not do? And I was able to just grind it out, and now that's kind of become how we do everything. It's not just me that does it at Big Ass Fans. It's, our entire design team has sort of embraced that philosophy, fail fast, iterate quickly, and that's how we get, the best product. We don't have to settle because of the cost of tooling. We just go, oh yeah, I'll print it again. And then once we're happy, then we spend the big money.
Sure. No, that's awesome. And so we were talking a little bit before kind of we hit record about some of the different projects you've done throughout your time there. Do you want to highlight kind of one or two of those projects that have really been impacted by kind of your work and 3D printing across the company?
Yeah. So I've got, so these, little bitty piece, about the width of my hand, and I don't have very big hands. So this is not a big piece, very thin. And then a little mating component. So the way that these would go together, they just sort of slotted in. This is not anything crazy or advanced, and we didn't innovate some kind of crazy material or do anything. This is polycarbonate. It was printed on a $3,500 Kickstarter printer. And so what this went into was a motor development project. We have a product called PFD early on in its infancy. So I had only been with the company about a year and a half. And this was one of those conversations that was like, well, maybe Mike can print it. And it was meant to just be a physical representative thing to get an idea. And I kind of pushed the envelope and said, well, if we buy polycarbonate, I think I can print it. We can try it. I'd never used polycarbonate before. I knew it was going to take more temperature. I did not know how much extra work it was going to be. So we buy polycarbonate and we start printing these things. And now all of a sudden it'll hold up to the temperatures of a working motor. So we didn't just, get a physical prototype. We literally built motors by hand. We were hand winding motors. We were putting these pieces in. And what was important about those pieces is you get steel laminations, but you have to insulate it to stop it from shorting out whenever you do all your windings. But the other thing was that typically when you do a motor design, that's over molded, which is really expensive. And so if you wanted to prototype it, you've got to make your laminations, and then you've also got to send all those out, let those get over molded, and then they come back, and then you put it all together and you hope that it works. Well, with 3D printing, we were able to adjust the wall thickness of those insulators and use as little as basically we thought we had to, which let us make a more and more efficient motor. But the other important aspect of this was that we didn't have to settle on a design, because we could make one. And the way that these laminations are made, I'll share a picture here. Let's see. And so the way that these are made, typically there is a sort of just a stack of metal sheet that are all stacked and compressed together. That's what you see here. So this is your lamination, and then the insulator goes around. So this is the 4 pieces of the insulator. Are you able to see it?
Yep.
Okay, cool.
And we'll post this for those who are just listening on audio too. So
yeah.
We'll throw this up.
And so basically we would take these steel pieces, and if we wanted to make a larger motor, we could just stack more pieces. If we wanted to make a smaller motor, we could stack less. If we wanted to make a thinner lamination for some kind of efficiencies, or because we wanted more poles in it, or whatever it may be, I'm not exactly a motor expert. I did a lot with this project, but say what I remember, we could just adjust this end cap piece to make it thinner or wider or whatever we wanted to do. And then we just hand wound the actual piece. And we varnish it and everything. And so we had gone back. We bought 2 3D printers to accomplish this. It cost us about $20,000 in printers and materials over the course of a year and a half, 2 years. We had gone back at some point and kind of looked at the cost of, well, what if we did all these iterations up till that point, and we had to send it out to get over molded and all this. And it was the difference between $20,000 and spending $500,000 to $2 million. Yeah.
That's awesome.
Yeah. And so for big ass fans, I've always felt like that was a turning point for us. That was the project that it took to take 3D printing from this thing that we can do, or this thing that Mike does, that's cool, or I can make pretty parts, or I can make whatever, a fixture here and there. But that was impactful. That's for a business to say we were able to make the most efficient fan in the market because of this kind of development. And not only did we do that, but that we cut the development costs by more than 10x, 20x or 200x in the case of $1 million, right? And so it was huge. It was impactful. It showed that even with hobbyist level technologies and $50 rolls of filament spools on an FDM printer, that we could kind of revolutionize the way that we innovated internally.
Sure. And as I think about it more, like what when you say kind of more efficient kind of systems, like what, when you're designing fans, like what are the considerations that you're thinking about? Obviously, I mean, it's a big metal rotating thing above your head, so it's got to be safe, but I'm guessing if there's vibration, like how you're moving the air, weight, I'm sure, and how much electricity it is, like what are kind of the things that you guys are thinking about as you're kind of working on these different projects?
Sure. So we're meticulous with it. So we have some tried and true designs that we know work. But even if we're using the same material for, say, the blade, and then the attachment point, which is the hub and the spars, it's all the same material and it's about the same size and it's about the same weight, right? Well, we still take those items and we put them on a shaker test. And all a shaker test is it's these giant fans at whatever the largest size is, because that's going to be the heaviest and where the most stress is going to be put on those points. And we literally built a machine that just takes the whole fan and bounces it up and down. And so you'll walk into our lab and you'll see it's almost like a spider. It's just flopping up and down off in the corner somewhere. And so we do this for millions of cycles to ensure that it's going to survive. But even beyond that, even though we know that those are going to last millions and millions of cycles, we still have hub retainers. So these are little laser cut metal brackets that attach the spar and the hub and the blade all together. And then somewhere along the line, that wasn't good enough either. We had seen, it wasn't one of our products, but we had seen a scenario where a blade had come dislodged. And we were like, well, all of our systems will prevent that. We know that, but we want to give people that extra level. So we put more time into R&D, and now we have what we call the foil retention system. So this is a high quality nylon strap that was taken and it attaches to the center of the hub at the point where it mounts to the motor or gearbox. And it runs all the way down the blade and attaches at the other end. So even if a blade broke or a spar broke, or then you somehow broke the retainer and you somehow sheared the, the bolts that we specify, it would still stay up. It would still stay in the air. And beyond that, we have all kinds of redundant safeties beyond that. We have large steel cables that are tying the lower portion of the fan to the upper portion of the fan that are holding the gearbox or the motor to the frames, and then holding again another set that's holding your frame to your building. We've never had an issue with this. We've never had a major safety concern, but we kind of guide ourselves to say we never want to. And so there's a lot of safety that goes into it. But beyond that, it's we have competitors within the market, and we've always want to be the best. So we make the biggest fan, we make the fan that puts out the most air, and we make the most efficient fan on the market in pretty much every segment that we're in. If there's someone who's moving more air than us, I can assure you that they're almost always doing it at the expense of twice as much energy. And so we tend to live in that, that's we're most efficient, or we're the biggest, or we're the baddest. That's kind of the big ass way.
Do you see the sustainability issue? I mean, you mentioned like the efficiency piece. Like, is that something like more broadly in the 3D printing industry? You hear that all the time, but like, is that something that's kind of, I mean, that's hugely important, it sounds like, to your business, but like, has it increased? Like, are people more cognizant of that aspect?
Yeah. We've done a lot of actual research stuff with various schools, where we'll assist them in research, either by providing fans or providing they'll do testing within the university, and then we'll basically double check them. We'll test it within our facilities and compare notes and talk. And a lot of those things are based around efficiency and comfort, right? So as you go places that are hotter, or as you run into issues where it's hotter where you live than maybe it used to be, right? We can only keep running the air conditioner so much, right? It'll eventually take so much energy to cool something that it's not worth it. You see this in a lot of like desert locations. They don't have air conditioners. They just have, swamp coolers or evaporative coolers, or some sort of humidifier, basically, to bring the temperature down. And so we try to make an efficient product, and we try to work with universities that are showing how we can use fans, particularly fans that are very power efficient, to improve thermal comfort in an office environment or a home, or large areas. Large areas are really hard to cool. I mean, pumping AC into something like our 100 foot by 100 foot areas in the test lab is basically impossible. We have heaters and we have fans in that facility. We don't have AC. We do in the office, but in the larger area, everyone's fine. I mean, there's guys who've worked there for 14, 15 years, and they'll say, yeah, it gets hot, but it's never uncomfortable, because we have fans. And if you need another fan, there's probably one sitting in the back. You roll it up. One of the things that was told, to me, and that I say a lot, is that, a fan moving at the right air speed will change your perceived temperature by 10 degrees. And that speed is somewhere between 120 feet per second and 200 feet per second. At a certain point, you blow air so fast that it's disruptive. Either it's loud, or it's, blowing the papers off your desk, or it's too much, just in general, in some capacity. And so we try to make things that can deliver a very, very high volume of air at lower speeds. That's the original name of the company, was the HVLS Fan Company, and no one knew what that meant, but that's what it means, is high volume, low speeds. What that does is we can move more air in an area at those comfortable speeds. And so you can be in an 80-degree room with that air moving correctly, and you wouldn't know the difference than if you were sitting in 70 degrees in an air-conditioned space.
Well, the current name is much more catchy than
big ass fans. Yeah, just rolls off the tongue. That's for sure. Go ahead.
Yeah. So tell me a little. I mean, a lot of different people listen to the podcast. I mean, we're passionate about kind of educating people about different. Like, I started this mainly because getting people interested in additive and seeing all the different career paths that people take. So kind of upon reflecting on your own career, like what piece of advice would you give folks that are maybe starting now, or trying to say like, hey, is there a career pathway for me in 3D printing?
Yeah, I think there's absolutely a career path. And I've had a dozen interns or so that have worked with me in the past couple years. And I kind of say the same thing to all of them that I'll say here, which is 3D printing is this accessible resource to everybody that has an engineering brain. If you were in engineering 20 years ago, you weren't going to be allowed to just go in the machine shop and mill something out, regardless of how good you were at your strength calculations and all that stuff. And so we're kind of at a revolutionary time where you can take an idea from your head, stick it into a computer, and then feel it the next day. And that's something that no generation going into this field has had before us. And so I at length will talk about how 3D printers work and what material is this, and when they can use it, what projects are good for it. And it's almost, they get like a little side internship about 3D printing on top of their, big ass fans internship. But my advice is always to, if you can find a niche kind of like I did, where you can see a future there, pursue it. I'm an engineer by trade now. It's what I do every day. But I am still so passionate about 3D printing that it's almost a job requirement for me to be like, even if I don't 3D print on a day-to-day basis, once or twice a year, I'm going to go to AMUG or Rapid or one of these 3D printing conferences and just see what everyone else is doing, talk to the people that I know within the industry and stay involved. So my advice is find something that you're as passionate about as I am with 3D printing and never let it go. So, yeah.
Awesome. So just follow on kind of last question. You mentioned AMUG, you mentioned Rapid, kind of what, even kind of all the experience you're doing in-house, can you tell us about one thing that you're excited about, either in the industry, the work that you're doing, kind of your career in the next few months or even the next year or so?
So as I said, we are pretty much, I don't know if you can hear my dog, and I apologize. She's moving around.
You're going to hear my daughter coming up from her nap in a second. So.
So exciting. There is a lot of different technologies coming out. There's a lot more efficiency and focus in the 3D printing industry to actually make it more practical for production applications, which is not something that I've seen a lot in the past. So I'm excited for that as someone who has to work with a manufacturer every day. But on a personal level, what are the things that, as far as a piece or a product or some technology, is the GDP stuff that Massivit's doing. I'm baffled at how big and how fast that they can print that stuff. And it's just super cool. And I hope that whatever they're doing kind of catches on and more people start doing it, because when you're the only one, you get to charge as much as you want.
Awesome. Cool. Well, Mike, thank you so much for joining the show today. Excited for kind of all that you're bringing to the community and all the work that you're doing there. So appreciate it.
Awesome, man. Oh, thanks for inviting me. And as I said, my only hope is to continue to stay and drive 3D printing from whatever side of the fence that I'm on.
Awesome. Thank you, sir.
Appreciate it.